Hi everyone, this is Mike Fitz, your resident naturalist with Explore.org, the world's largest live nature cam network. And I'm glad you could join me today, no matter where you happen to be around the world. This is a live chat specifically about the ecology of Pacific salmon. When we're watching the bear cams, of course, the bears grab and garner most of our attention. But during this live chat, I really want us to consider the importance of the fish that many people, including myself, consider to be the keystone species of Katmai. And if you have questions on this topic, on their ecology, or their life history, or their biology, I'll do my best to try to answer those throughout the broadcast, and then also at the end of the broadcast too. So you can drop those questions into the comments at the bottom of the page that you're watching it on right now on the Brooks Live Chat channel, and the helpful moderators from Explore.org will forward those questions to me. I have some slides I want to show you. I have some video that I want to show you. This is, I think, Pacific salmon are one of the most fascinating groups of animals that inhabit North America. And I also think they're one of the most important animals as well. So to begin the broadcast, I would like everyone at home really I want to just pose a question to you. I would like you to think about why salmon are important. And I think there's sometimes some obvious things that pop into your brain when you think of that. I think, a lot of people consider salmon to be beautiful animals. We admire them for their endurance, their ability to survive against sometimes great odds. But of course, salmon are also important to many of us because, well, we like watching bears. We love bears. We like watching bears. We like seeing happy, fat bears, which they are at this time of the year especially. And that's, one of the benefits of salmon, of course, is to have a healthy and large bear population in Katmai National Park, where the bear cams are located. Of course, many of us think salmon are important because of the recreational opportunities they provide. A lot of people like to fish for them. A lot of people like to eat them. They end up providing, of course, economic opportunities and jobs, good-paying jobs, in areas where people can fish for them commercially, especially in the Bristol Bay area, which Katmai is a part of. So there are a lot of obvious things that make salmon important. But during the broadcast, I really would like us to consider how salmon are important in maybe some not so subtle ways. How might these fish that are so beautiful and so vital to people and brown bears, how are they important in different ways? And some of these things can be quite subtle. Some of these pathways that they are important. Like, how are they important to the forest? How might they be important to the insect life that inhabits the same places as the salmon? And how might they be important to the next generation of fish? And this goes beyond the simple act of spawning and reproducing. How are the adult salmon ensuring the survival of the next generation of fish? Those are some of the topics that we're going to discuss during the broadcast today, because Pacific salmon, I think, are one of the most important species or groups of animals in Katmai National Park. They're keystone, and their survival of this ecosystem is really dependent on the survival of salmon. To begin that, exploring this topic, though, I think we do need to understand a little bit more about their life history. So if you're not familiar with Pacific salmon, let's take a step back and think about what's happening in the river right now. Salmon are spawning, they're laying their eggs, and those eggs will incubate in the gravel throughout most of the winter. They'll hatch in late winter and spring. And what comes out of the eggs actually doesn't look very much like a fish at all. It's actually a larval fish with a large yolk sac attached to them. And those are called alevins. Those are what you see in the middle of the screen. Big eyes. They can barely swim. They really can't swim at all, actually. They just kind of can wiggle in place until they absorb that yolk sac. And that's their food source until they emerge from the gravel in the springtime. And then sockeye salmon in particular, which are the most abundant salmon species in Katmai, will spend 1 to 2 years in fresh water before they run to the ocean. So they're growing for a period of time in fresh water, growing to maybe to be just a few inches long before they run out to sea. And then they'll spend 2 to 3 years out in the open ocean, traveling thousands of miles during this time and gaining most of their body mass before they return to fresh water to spawn. And that typically happens in the Brooks River area and the Katmai region in late spring and early summer. That's when the peak of the salmon migration happens. And when the salmon first arrive, they look like this. They generally lack any bright colors. They're sleek, they're silvery, sometimes bluish when you view them from above, but that's just a little bit of light refracting maybe on their backs. At this time of the year, though, they look like a much different animal. Very strange in their appearance. They are deep red and they have deep red bodies, green heads, long hooked snouts. These are their physical characteristics that show to other salmon that they are ready to spawn. So these are their spawning colors, and this is what the fish look like in the river right now. If you've been able to tune in to the underwater camera, we've been getting some really wonderful views of fish on that camera right now. And what's happening upstream of the underwater camera, because the underwater camera is happening at the mouth of Brooks River, is that the salmon are spawning. The females will use their tail to winnow away the gravel to dig her nests. Males will fight with other males for access to females. So all of these fish are working very hard right now to spawn. But even if they're successful and they're able to spawn, that's it for them. They're coming here for one reason and one reason only, and that's to spawn and to die. So salmon are not only anadromous, meaning that they are born in fresh water, they go to the ocean to grow large, and then they come back into fresh water to spawn, but they're also semelparous, which means they only reproduce once. They die after they reproduce. So even if salmon are successful, their life's journey at the end, of course, immediately after they reproduce, leads to their death. And this is, I think, a dramatic example of their drive to reproduce. And we can witness much of this cycle in Katmai. We can witness much of it on the bear cams. But along the way, salmon have a huge impact on all forms of life. Their return, their lives, and their eventual death have impacts that ripple throughout the ecosystem. And perhaps the most obvious way that happens is, well, by just looking at the benefits that they bring to the bears. Salmon are an abundant, high-calorie food source for many of Katmai's creatures, and bears are highly dependent on salmon. Bears start to feed on salmon almost immediately in Brooks River once they begin to arrive, and that's because the topography of Brooks Falls allows them to do that. Bears are able to use the pinch points at the falls, the shallow water, and areas that make the salmon vulnerable to predation. Otherwise, in a large river like Brooks River, it would be difficult for bears to fish for salmon as successfully as they do, as commonly as they do. And it really is worth a bear's while to eat as much fish as possible early in the salmon run, because those fish are extremely high in calories. Each sockeye salmon contains about 4,500 calories per fish when it first arrives from the ocean. And when bears are standing on the lip or in the far pool, wherever they happen to be fishing, and they're eating 1 dozen, 2 dozen, or more fish per day, they're taking in tens of thousands of calories. And these are some of their first substantial meals since they came out of their dens several months before. Salmon are important to bears, of course, throughout the summertime at Brooks River. And right now, some bears are still trying to catch some of the last fresh fish up at Brooks Falls, but we're starting to see more and more bears down at the mouth of Brooks River, scavenging for any dead and dying salmon. So bears are certainly not shy about picking up salmon carcasses, but those fish aren't necessarily as valuable as when you want to think about them from an energy standpoint as a fish that's fresh from the ocean. But they're also very easy to catch. All a bear has to do is just walk or swim through the lower river right now, and they're able to find many, many salmon carcasses to pick up and scavenge. Of course, it's just not bears that are benefiting from the energy and the calories that salmon bring back to ecosystems each year, but wolves will feed on salmon, sometimes at Brooks River, but throughout much of Katmai, they are feeding on salmon throughout the summertime and much of the Alaska Peninsula. This has been demonstrated in studies from the Alaska Peninsula and also from Southeast Alaska. I like to consider salmon to almost be like French fries in that almost everything likes to eat them. So if you are able to consume salmon and digest them, if you're an animal living in Katmai, you're probably going to want to try to take advantage of this summer bounty that comes every year. And of course, it's just not the stuff on the ground, but it's the animals that can fly through the air. Bald eagles, the number of bald eagles increases substantially when salmon are at Brooks River, salmon are migrating and spawning. And bald eagles, like many other birds, are also scavengers. The gulls and the magpies especially will come to Brooks River in large numbers once the bears start feeding on salmon. Because even like a bald eagle, a fresh sockeye salmon, a whole live sockeye salmon is just too big of a catch for a magpie, for a gull, and even for a bald eagle. So a lot of these birds are waiting for bears to strip the skin off of the fish, eat the brain, maybe eat the eggs, eat some of those higher calorie parts of the fish, and leave carcasses behind. And bears will do this frequently when they're well fed. They're going through they're behaving in a manner that allows them to high grade the fattiest parts of the fish, because bears can digest fatty tissue very efficiently. Why waste stomach space on lean protein when you can get more calories through fat? So bears are helping to transfer the energy of salmon nutrients to everything that happens to be waiting in the wings. The energy that salmon provide to these ecosystems are not only important to the survival of animals that we can see above the water, but also below the water too. This is an image of a caddisfly. Caddisfly larvae are actually quite interesting animals because they will camouflage their bodies using bits of debris that they find on the bottoms of streams. So it really just depends on the species and the substrate. You may find them camouflaging themselves with sticks and bits of leaves. This species here just happens to be using more pebbles than anything else. But caddisflies, different species, are shredders. Maybe they'll go after plant matter that's in the water, but some of them will actually feed on animal matter in the water as well. And caddisflies will quickly colonize salmon carcasses that are left in the water. And studies from Washington State have actually demonstrated this. So when we're seeing a bear stripping the skin off of a fish, leaving carcasses behind, they are, again, transferring the calories, the energy from salmon, to dozens of other species, making these fish available to a wide variety of animals. Of course, it's just not the flesh that's important to these fish, or excuse me, to wildlife, but it's also the eggs too. And in fact, really, if you had a choice between salmon eggs and salmon flesh, I know a lot of our palates probably would want to choose a salmon fillet, but when you think about it strictly on a calorie standpoint, if you're looking to maximize your energy intake like a brown bear is, you've got to choose the salmon eggs. For an equal weight, excuse me, salmon eggs are 6 to 7 times richer in calories compared to an equal weight of salmon flesh. So they are nothing but just a packet of fish oil, and they are extremely valued by all sorts of organisms, including bears and birds, but also the fish that live in the water. Brooks River and the other waters in Katmai National Park are famous for their rainbow trout. Large numbers of rainbow trout and trout that grow to very large sizes. And these are all homegrown fish. They're not stocked. They're not farmed. They are not raised in hatcheries in any way. They're all wild fish. And some of the rainbow trout in Brooks River can grow to over 30 inches long. And when you see footage of salmon spawning, when you see that spawning event, when the females are releasing their eggs, it's not uncommon to see a fish like a rainbow trout or an Arctic char or a Dolly Varden or another fish species diving in right at that moment into the nest, like a Dolly Varden here, to grab the salmon eggs. And fish right now in Brooks River are gorging on salmon eggs. And to help illustrate this point, I have a slide that I want to give everyone a heads up about, because it is a picture of a gutted fish. The next one coming up is of a gutted fish, but I think it does really help to illustrate how important salmon eggs are to many of these species. And a little bit of the backstory about the next photo. This fish was caught by a ranger that I used to work with at Katmai. He was at a place, a different stream. You're allowed to keep fish in those places. So he brought it back to his cabin. He was going to eat it, of course. But when he looked at the fish, he could notice, or he saw that its stomach was visibly distended, and he was wondering, well, just what is inside of this fish, this char's stomach. So when he took out his fillet knife and he started to clean it, he cut open the stomach, and this is what poured out. Hundreds of salmon eggs. In fact, rainbow trout and Arctic char probably aren't eating very much in Katmai during the winter time. There's just not a lot of stuff happening in the winter for them to eat. So the fat that they can gain, the energy reserves that they can gain right now at this time of the year from salmon eggs, helps to sustain these fish through the winter. So we think of just the brown bears as the one really benefiting the most from salmon. But again, the energy that these fish are bringing back into the ecosystem each year are valued throughout much of the food chain and the food web. So when you're seeing a bear licking, every last egg off of a rock, that bear's, being smart with it and efficient with its use of time, because those eggs are just so valuable. And that again helps to illustrate one of the pathways that salmon help to impact the ecosystem. Of course, this isn't the only way salmon are impacting the ecosystem. Certainly the energy that they bring to freshwater and terrestrial ecosystems each year, it can't be ignored. But is their importance only limited to energy? And what role does a dead and decomposing salmon play in the ecosystem? For a moment, let's consider the characteristics of an Alaskan lake. The average Alaskan lake, when it's not filled with glacial sediments, of course, is very cold and very clear. That's an indication, though, that there's not a lot of productivity, meaning there's not a lot of plankton growing in the water. There's not a lot of nutrients available to support the growth of plankton. And maybe you can compare those cold Alaskan lakes with some lakes that you might have in your area, especially if you live in the southeastern United States. You can take a look at a river, or you can take a look at a lake and see that you can't look very far into the water often, because there's just so many things growing and so many nutrients available in those waters each year. And also another important characteristic of these Alaska lakes is that they can become stratified, and that you can have a warm layer of water on top, a cold layer of water underneath in the summertime, and that helps to prevent nutrients from staying in suspension, nutrients that would otherwise feed the plankton that are at the base of the food chain. And this happens in the winter time as well. The water is very cold and stratified, and there's not a lot of mixing going on. Now compare the characteristics of these relatively low productivity waters with what happens out in the North Pacific and the Bering Sea. Of course, these waters are cold and they can be very clear at times in certain places, but they are highly productive. And really the difference is the fact that the waters are almost constantly mixing. They're churned by strong winds and upwelling currents, and that helps to keep nutrients moving throughout the water column. And especially in the summertime, that makes these areas very productive, and areas where fish can grow rapidly. And remember, this is where salmon are going to gain most of their body mass. They're not gaining most of their body mass out in freshwater, not in Brooks River, not in Naknek Lake, maybe where they're rearing for a couple of years before they go to the ocean. They're gaining 99% of their body mass out in the open ocean. So think about these fish not just as a bundle of energy, but think of these fish as a sack of fertilizer. 4 to 7, maybe 4 to 8 pound sack of fertilizer. Millions of pounds of fertilizer coming back into these relatively nutrient poor freshwater ecosystems each year. And these nutrients are transferred through the ecosystem in a variety of ways. Of course, bears are an important way that happens. They carry salmon carcasses up into the forest. They don't eat the whole fish. They leave carcasses behind. They're also carrying salmon in their stomachs. And as that digestive process continues, of course, it comes to an end at some point, and they're depositing scat throughout the forest. And there's a reason why farmers, put manure on their fields, because when food is partly digested by an animal, and it is evacuated out the other end, a lot of that is in a state that's readily accessible for plants to rapidly uptake through their roots and into their tissues. And really, it's not an exaggeration to say that many of the trails and the riverbanks at Brooks River right now are just covered in bear scat, almost like a layer of bear scat. So when I went to, when I was a ranger at Katmai and I spent time there in September and October, I was always sure to take my boots off when I entered my cabin, because you were definitely walking through this stuff. It was nearly everywhere, and it's through the forest as well. And this is, again, helping to fertilize the ecosystem through their scat, through their urine. And anytime that you're walking along a salmon stream and you happen to see salmon bones, you can rest assured that the plants in that area are being enriched by the fertilizer that salmon bring back to these places each and every year. Of course, there gets to be a point when not even a bear will eat a salmon. A lot of the salmon at Brooks River are scavenged even after the salmon happen to die. But there gets to be a point where a bear will say, you know what, enough is enough. So what about these fish? What about these fish that are not being processed by bears or eaten by other animals? Well, even their nutrients are incredibly important to the ecosystem. You can see in this little bit of a video of what's left of a salmon. This was a video that I took near the mouth of Brooks River a few years ago. This fish is just covered in fuzz. And that biofilm, the fungus, the bacteria, the algae, everything else that's living on this fish and decomposing it helps, of course, to transfer the energy of the fertilizer of salmon to anything that would happen to feed on the bacteria or the fungus. But also that biofilm can sometimes help to transfer salmon nutrients, perhaps even under the gravel as the water is flowing through the area, because most of a river or stream most of that water flow is actually out of sight where we can't see it. It's below ground. And this is the entirety of Brooks River right here. This is the whole 1.5 mile segment of Brooks River. This is what it looks like around this time of the year during fall, when we first start to see snow laying on the mountains. So it's a beautiful sight, but each one of those marshes and the trees along the riverbank, they may be tapping directly into salmon nutrients if their roots are kind of reaching that water table where the fertilizer has been transferred and is now flowing underground thanks to that biofilm. So salmon are certainly in the trees. That is not a figurative statement. The nutrients of salmon are being utilized by the forest, by the marsh that is growing in these areas where salmon spawn. Now, of course, I could talk about this in a hypothetical sense, but is this fertilization really occurring, or is it just something that we surmise? How are we even aware that salmon are enriching the ecosystem in this manner? And how does the abundance of salmon play such a vital role in increasing the productivity of Katmai's land and water? Well, I think this is one of the more fascinating things about salmon ecology, is that we can actually trace salmon nutrients through the ecosystem. And to understand that, we have to maybe go back to high school chemistry and think about how elements have different isotopes. One of the most common elements on Earth is, of course, nitrogen. It's most of our atmosphere. It's an important component of all of our bodies. On the land, there's an isotope of nitrogen, nitrogen-14, that's very abundant. So in areas where, if you're living like an existence that's basically terrestrial based, you're going to have a fairly high amount of nitrogen-14 in your bodies. Now, there's other isotopes of nitrogen that are also found in terrestrial environments, but one of those isotopes of nitrogen is found in a slightly higher proportion in the oceans, just because it's heavier. So it flows downhill with the water, accumulates in the ocean. That happens to be nitrogen-15. So to trace the pathways of salmon nutrients through the watershed, you can take a look at the ratio of different elements like nitrogen and find that somehow nitrogen 15 is found in higher levels in areas where there are salmon. And you have to think about, how do these elements get to these places? Again, salmon are gaining most of their body mass out in the open ocean. So they're gaining, they have a higher proportion of nitrogen-15 in their bodies compared to an animal that would live a purely terrestrial or freshwater existence. So you can take a look at a leaf, you can grind it up, you can take a look at the ratio of nitrogen-15 versus nitrogen-14, and if you see elevated levels of nitrogen-15, you got to think, how did it get there? And really the only feasible way for that element to get brought into these freshwater ecosystems in large numbers is through salmon. So we can directly trace the pathways of salmon nutrients through the ecosystem each year. It's one of the more fascinating things, I think, that I have read about with salmon ecology. So through simple decomposition, the nutrients from salmon, they impact every strand in the food web. So certainly salmon are important, but what would the loss of these impacts mean for areas that no longer experience large runs of salmon? A lot of fisheries biologists now think that this whole cycle of salmon coming back into freshwater to spawn in large numbers is a positive feedback loop for the young salmon. Because of course, if you have more fish, maybe you're going to have more eggs, right? Maybe more eggs hatch. But without the large numbers of salmon nutrients sustaining the bloom of plankton that happens every spring, you probably don't have enough food in many of these places for large numbers of salmon fry to survive the 1 to 2 years that they need in freshwater before they go out into the ocean. Which raises a lot of, I think, important questions about how we can restore salmon runs in areas that no longer experience very large runs. Is it as simple as just removing dams or removing barriers, improving habitat, or removing barriers to their migration and improving spawning habitat? Or maybe is there a little bit more to it? Do we need to think about actively fertilizing some of these watersheds so young salmon can survive in greater numbers. When we see how salmon are important to bears and people, I think it's really easy to understand their impact. And when we start to investigate, however, we start to see how salmon impact much, much more, how they're important to the survival of much, much more. They're important to the insects, which in turn feed the birds and other animals. They're important to the forests and the marshes that become more productive because because these places are fertilized by salmon nutrients. And they're important to the next generation of salmon who survive in greater numbers when their waters are enriched by salmon carcasses. The legacy of salmon extends to nearly all life in Katmai. These are fish that transcend boundaries between the ocean and the land in ways that few organisms can. And in this wounded world, during an era of mass extinction and human-driven climate change, Katmai National Park is an increasingly rare example of a healthy ecosystem that's functioning at its full potential. Bristol Bay and Katmai represent the last great salmon run on Earth, and it offers a stark contrast to the state of salmon elsewhere in the United States, where nearly all salmon runs outside of Alaska exist at fractions of their historic highs, and many, unfortunately, are at risk of extinction. But the survival of salmon and the ecosystems they inhabit are not guaranteed. We could lose salmon, we could lose what we value at Brooks River to incompatible development like mining. Salmon populations will almost certainly suffer from the impacts of climate change too, especially in areas where their populations are already threatened by habitat loss and our demand for water. Like the millions of people who are striking around the world today, this is yet another reason to demand our governments take meaningful action to address the impacts of climate change. And when salmon disappeared in the past, it was merely thought to be just an aesthetic loss or an economic loss. Now we know that when we lose runs of salmon, it's more than just those things. It's also a tremendous cultural and ecological loss. And the fact of the matter is, without salmon, we wouldn't be going to Brooks River to fish for trophy-sized rainbow trout. We wouldn't go to Brooks River to see one of the greatest concentrations of brown bears on Earth. We wouldn't be watching a webcam, enjoying the sight of brown bears fishing for salmon. Katmai National Park wouldn't support one of the largest and most dense populations of brown bears on Earth. The Brooks River would not have sustained indigenous peoples for nearly continuously for the last 5,000 years. And Bristol Bay today, modern Bristol Bay, would not have a multi-billion-dollar sustainable fishing industry. None of these things would exist here without these fish. So for salmon, for the organisms that depend on them, including ourselves, we need to ensure that we support sustainable fisheries, that we protect and work to improve watersheds, and that we mitigate the impacts of climate change now before it's too late. We need to do these things to ensure the survival of salmon and the ecosystems as we know them. And I'm glad everyone could join me for the broadcast today. Again, my name is Mike Fitz with explore.org, and I hope you never stop learning. And I'm going to try to get to your questions during the rest of the time that I have here. So I know that there are several in the queue right now. So I think maybe a few of those I was able to answer during the more formal part of the presentation, but I'll try to do my best to answer any of those remaining questions that I have here. So let me check and see what people might have dropped in here. So how was the salmon run different this year? Was it larger, smaller? Was it earlier, or was it later? There actually were several differences between the salmon run this year and the salmon run that we had last year. So in 2018, the salmon run in Bristol Bay was the largest on record. Something like 62 million salmon came back into Bristol Bay. The escapement, though, the number of fish that survived the commercial fishery and they swam upstream to spawn into the Naknek River watershed, which is where Brooks River is located, was actually larger this year. So they had just harvested a few more salmon last year out of that would otherwise come to Brooks River last year compared to this year. But it was, I mean, everything up there in Bristol Bay is just gangbusters. I mean, it is the area is just flooded with fish. So the past 2 years have been exceptionally large runs of salmon, so that's a similarity. One of the differences, again, was the escapement was a little bit larger this year compared to last year. One of the other really big differences was the timing of the migration and the spawning, and it seemed to be greatly impacted by a heat wave, an unprecedented heat wave that happened in late June and early July. The water temperatures in Brooks River got very, very warm, hotter than I had ever experienced them before. I went into the water to clean an underwater cam, for example, and I could go in there without any discomfort at all. Normally, when you go into waters in Alaska, you feel that sort of that cold chill on your body. You have that involuntary gasp that accompanies going into cold water, but I just walked in like it was a warm pool. I mean, it was incredibly warm. I'd never experienced that before. And when water is really hot, that's not good for salmon migration or spawning because it increases their metabolism. So the salmon are expending more energy, and at the same time, it increases their demand for oxygen, while the water, as it warms, carries less dissolved oxygen. So the salmon in Katmai are fortunate in the fact that they can just kind of hang in the lakes in those situations and wait for the water temperatures to cool off. And I think that ended up delaying a lot of the spawning activity for some of the smaller streams where salmon typically spawn in August. And maybe that ended up delaying a lot of the bears coming back to Brooks River. So it seemed like the salmon run was just the timing of spawning in many places was a little bit later in those smaller streams in August this year, just because of those warm water temperatures. So let's see. We've seen massive declines in sea bass that's believed to be related to the blob of unusually warm water in the Gulf of Alaska. We're also seeing near record runs of sockeye in Bristol Bay. Is it possible that salmon could be taking over some of the habitat and food resources left unused by bass and other fish? I don't know. It's an interesting question to ponder. When fish, don't in the ocean, they overlap in a lot of their niches. So young fish, for example, they're feeding on, from a variety of species, are feeding on plankton, and sockeye salmon out in the open ocean don't really feed on fish like king salmon or silver salmon or chum salmon that grow really, really, really large. The sockeye salmon are mostly feeding on krill and more what you would consider more planktonic organisms. So it's possible that there could be more food in the North Pacific because of current conditions right now for the sockeyes. It could be because there's less competition from other fish. I don't really know. We do have to be careful, though, of what happens to the ocean, because no matter what we do to protect freshwater ecosystems, like Katmai is highly protected right now. It's a national park, very limited development. So the watersheds are very, very healthy and resilient in the face of like climate change, for example. But what happens in the ocean, if the oceans can't support salmon, it doesn't matter what we do on the land to protect their spawning habitat. So we need to ensure that the oceans remain healthy as well. So things are definitely changing in the North Pacific. I know a lot of fish species that were formerly found farther south are moving north, north through the Bering Sea. And how this will affect salmon in the long term, I'm not really sure if anyone is sure of that. So I think it's a very complicated process. The ocean is big. It's a complicated ecosystem. So I don't know if I could really answer your question all that well, but it's quite possible that if certain fish species in the ocean decline, then there could be more food for other fish, and it could be salmon, it could be something else. And can there be too many fish returning to an ecosystem? Potentially. And that's why the Alaska Department of Fish and Game really tries to even out the salmon runs that return each and every year. So they try to manage the commercial fishery. So enough. Of course, the number one goal is to make sure that enough salmon return to freshwater to spawn, to continue the cycle, to sustain the fishery and the wildlife that depend on them in the future. But when you think about very small streams, sometimes they could potentially get overwhelmed with spawning salmon, especially when spawning habitat in those small streams is limited. So one of the main ways that salmon eggs end up dying is that if you're a female salmon and you pick a good place to spawn, you try to stay there as much as you can to protect that spawning site from other females. But after you die, maybe another female will come on in and she'll dig her nest in the same spot so they can displace some of those eggs. And that happens enough times, maybe that in small streams that could end up lowering the overall reproductive rate and survival rate of salmon eggs. So it's possible. In other really small streams, if salmon, don't have the ability to avoid really warm water with low oxygen, they could suffocate if there's too many fish in the stream. So that could happen as well. So there are definitely scenarios where too many fish could return. And we have to, you think about the thousands and thousands of years that salmon were spawning in Bristol Bay watersheds and elsewhere in North America before large-scale commercial harvesting of them started to occur. And really, that didn't occur in Alaska until the late 19th century and early 20th centuries. I mean, there were throughout time just huge spikes in salmon productivity for a number of decades or hundreds of years, and then it would just tank. And that probably was related more than anything else to productivity in the ocean. So again, so no matter what we do on land, that helps us again to underscore how important healthy oceans and ocean productivity happen to be to the survival of large runs of fish. And we know that salmon populations over decadal timescales go up and down, not only from our records over the past 100 years or so, but also from sediment cores. Again, going back and looking at those isotope ratios of nitrogen 14 and nitrogen 15, if you take a core of lake sediment from lakes in Katmai, you can measure again the ratios of those different elements, and you can see when you have elevated levels of nitrogen 15, it probably indicates that there was a lot of salmon in the watershed at that time. And then there are also periods of time where there's relatively low levels of that nitrogen 15, indicating that maybe a lot didn't come back. And somebody's wondering if there is a distinct advantage for fish who are anadromous as opposed to those fish who live in spawn in saltwater or freshwater only. It's hard to say. One of the advantages though of anadromy is that you get to grow larger faster. So if you were a salmon that's trapped in fresh water, and there are populations of sockeye salmon that are trapped in fresh water and they complete their whole life cycle in fresh water. Those are called kokanee salmon. There's a couple of populations in Katmai. I know there are several in Washington State. There are in British Columbia and Alaska. Those fish, they don't grow nearly as large as a fish that goes to the ocean, and they grow a lot slower too, just because there's not as much food available in the lakes where they happen to live, because they don't have like the influx of salmon nutrients and energy coming into the watersheds each year. So for freshwater fish, yeah, you tend to grow slower, and maybe for a salmon, your maximum size when you reach reproductive age is just a little bit smaller. And if the bigger the salmon, the more eggs you can carry, the bigger the gravel, the deeper that you can move with your tail, the deeper the nest you can dig to protect your eggs. So there are some advantages of being large. Out in the open ocean, maybe spawning habitat could be more limited. Some fish, we tend to think of the odds of a salmon egg surviving are very, very low. Maybe a female sockeye salmon will produce several thousand eggs, maybe 4,000 eggs or so, and maybe only one or two of those eggs will survive to return to be adults in fresh water and spawn. But you think about some species that spawn in the ocean that are broadcast spawners, like cod, like Atlantic cod. I mean, they broadcast like millions of eggs. I mean, think about broadcast spawning coral. I mean, they just kind of release, milt and eggs into the water all en masse, and very, very few of those eggs will ever find, a place to grow into an adult. So moving back into these freshwater areas may offer advantages to knowing that you have a specific spawning site, sort of waiting and available for you, and maybe that helps to increase the survival rate of those eggs overall. And have there been any studies about what percentage of salmon calories and nutrients make it onto the land? I'm not really sure if anyone's ever been able to track that. Again, I think we know that maybe the easiest way to evaluate that would be through their nutrient loads. However, one way that biologists are able to track, the relative percentage of food that predators, or excuse me, I'm going to back up a little bit and say this a bit more clearly. Biologists are able to estimate the number of salmon that certain animals eat, and they can do that by just looking at hair, because hair is basically kind of like an inert thing. It grows, and then when it's what's left after it's done growing is a record of what the animal was eating at the time. So again, you can look at isotope ratios. You can look at different elements. I know, by looking at the relative amount of mercury in salmon, biologists on Kodiak Island have used that to estimate the amount of salmon that brown bears on Kodiak Island eat, and it's thousands of kilograms a year for some bears. I wrote a blog post on this last September, and it's on Explore.org's blog. Maybe somebody can post that, a link to that in the comments, because it's kind of a fascinating way for us to evaluate how much energy brown bears are intaking from salmon each year. And then biologists have used this in wolves as well. They've taken a look at the whiskers on wolves, because whiskers grow, and as they continue to grow, they record, certain snippets of time that may tell a biologist looking at the isotope ratios in those whiskers that, hey, maybe they're eating a moose, maybe they're eating a caribou, perhaps they're eating salmon at this point, because we see a spike in the isotopes that are found more commonly, or in a higher percentage, in the ocean. And I know that's been documented for wolves on the Alaska Peninsula, and it's also, perhaps been documented in elsewhere in North America. So there are ways, but it's maybe a little bit more convoluted to get to the bottom of of your question. Have there been studies about what percentage of salmon calories and nutrients make it onto the land? There are certainly ways to do that. Somebody is wondering, is there fish farming in Alaska? No, there are no fish farms in Alaska. Fish farming is permitted in British Columbia, however. It used to be permitted in Washington state, but the state legislature in Washington passed a bill last year, I believe, that outlawed salmon farming in Washington state, and that was primarily to protect wild salmon stocks because there's considerable evidence that shows that farm salmon can transfer disease to wild salmon stocks. And in the Puget Sound area, right now there's an endangered population of orca whales that feed almost exclusively on salmon. So we need more salmon in the water in Puget Sound, the Salish Sea, and other areas nearby to sustain that declining population of orca whales. And right behind me, you can't see it, is the Skagit River, which is one of the most important salmon producing rivers for Puget Sound. So I'm part of this this process as well. I have to make sure that whatever I'm doing is not unduly impacting the watershed, to ensure that the salmon that are using this river, and there's a lot of salmon in the river right now trying to utilize it to spawn, are not impacted by my activity here. So, and if you're living in areas away from where salmon spawn, you can help salmon by supporting sustainable fisheries. Of course, and like I mentioned before, making sure that you are demanding, essentially, we're at that point in history where we need to demand that our governments take action to mitigate the impacts of climate change. I think those are two of the greatest things that we can do to protect salmon for not only ourselves, but the orca whales and everything else that happens to depend on them. Somebody was wondering about that picture that I showed of the bear scat. I can probably bring that back up for you. I know it's everyone's, of course, right? Everyone's famous or favorite, everyone's favorite slide that I have in this program. They were wondering actually if it is otoliths in there, and an otolith. Excuse me. Let me bring the photo up here. There we are. An otolith is an ear bone. It's a round ear bone. What you're actually seeing in the photograph, though, are not otoliths. Those are vertebra from salmon. So, and there's some rib bones in there too. So, bears. I don't know how bears do it, but they have their digestive tract is extremely tolerant of a lot of these things. So, I mean, and their gullet too. I mean, they are just swallowing huge chunks of salmon with hard bones in them. So yeah, what you're seeing in there, those round pieces, are actually salmon vertebrae that pass through a bear's digestive tract. And is there a way to tell a male salmon from a female salmon? There is. In fact, I don't know if we'll be able to take a good look on the underwater camera right now. They're not really giving us the best view, but the easiest way to tell a male salmon from a female salmon is to look at the size of their hump. A male salmon will have a much more exaggerated hump than a female, and that fish that kind of just drifted into view looked like it was a female, just because it didn't have a very large hump. So males tend to have longer hook jaws and a bigger hump. So the differences in spawning colors on sockeyes, male versus female, they're really not a difference in color. It's just the body shape overall. So males tend to have a larger hump and longer, more hooked jaws than females. And the difference might be, again, it might have evolved to help them on their spawning grounds, because males need to fight other males for access to females, so that those big hooked jaws might help you to bite other males. But at the same time, that big hump might make it harder for other males to bite you. So that's a possibility for why the salmon might attain those big humps. Some biologists often think, or have hypothesized, I should say more accurately, that the large hump on males happens to deflect predation away from females, because a male can fertilize the eggs of multiple females as long as his energy. He has the energy to do that, but a female, has a limited number of eggs. So again, if there's some truth, or a lot of truth to the saying that sperm is cheap. You don't really have to produce or have to use a lot of energy to produce a lot of sperm, but females can only carry a finite number of eggs. They can only produce a finite number of eggs. So maybe they don't get those exaggerated features also because a male is maybe deflecting a little bit of the predation away from female salmon. Again, that's a hypothesis of some biologists, but we don't really know for sure. We're getting a good look right now at sockeye, and then also a silver salmon that just popped into the frame. You can see the spots in the green back on that silver or coho salmon. So very different looking fish in their spawning colors than sockeyes, but I don't think any less beautiful. So the underwater camera right now, I think, is one of the best cameras that we have on explore.org. I know it doesn't get the attention that the Brooks Falls cam gets, but it's a really wonderful scene, a beautiful scene right now. And I think that's most or all of the questions that we have time for today. Again, I would like to thank everybody for joining me during this live broadcast today about the ecology of Pacific salmon. I hope it helps you to better understand their importance, not only to brown bears and people, but also to the rest of the ecosystem. They are the keystones of Katmai and the survival of Katmai's ecosystem, and the things that we value about this place are highly dependent on these fish. So we do really need to work to ensure that they survive long into the future. Again, my name is Mike Fitz with explore.org. Thanks for joining me today, and I'll talk to you soon.